Hey, in this video we'll have a look at another way to use the prolog append predicate, and we'll use a couple of variables, x and y, and what we'll do is we'll split this list apart, and x and y will store all the different ways that the list can be split apart, and the results are shown on the right here. It can get a little bit messy, so I'll probably try and just keep it as short as I can, but sorry if the video goes a bit long. It's just best to go through it slowly to sort of get the hang of how it works. So the knowledge base on the left here, we've got the base case first, followed by the recursive case. So what prolog does to start with is that it takes the query term and it starts at the top of the knowledge base, scans line by line downward until it finds a matching fact or rule that it can unify or match this term with. So the base case can be matched with this term. It meets the unification rules. So that means that the base case is the first thing that prolog calls. And when prolog does this, it sets up x and y to have their own memory address. And in prolog, an underscore and a G is a way to refer to a memory address, and then after the G is normally a random number. So what it's saying is that x will equal the value stored at the memory address G1, and likewise for y. So yeah, the base case is called. So now prolog has to try and find values for x and y, and this is like part of the unification process. Prolog will just look at the corresponding arguments. So argument 1 has a variable x up here, and then it's got an empty list here. Variables in prolog can accept any value. So to make these two terms or two arguments equal, all prolog has to do is bind empty list to x, which means G1 will equal the empty list, because if both these first two arguments empty lists are obviously the same thing, so prolog's happy with that. Prolog goes on to the second argument, tries to find what y could be, so how to make these two things equal. But if you just skip ahead here and look at the third argument here is list, which is a variable. Up here it's an actual value of list of ABC. So keeping in mind that prolog variables can accept any value, all prolog has to do to make the third argument equal is assign this list ABC. So this list gets ABC. Therefore, these two third arguments are exactly the same now. But because these two lists have the same name, they have the same value too. So when a value gets bound into this variable, it gets shoved into this variable too. And because we were wondering what the second argument was, we now know what it is, because this value got pushed into this variable anyway during the third argument binding. So now we know what G2 is. G2 is just the list of ABC, and the base case has done its job now, which means G1 is the empty list and G2 is the list ABC, and that's exactly what prolog prints out to the console for the first one. And if you do a trace in the terminal, this is what we just printed out, and if you press a semicolon, you'll see this redo thing here, and redo is saying backtrack back up, and when you do backtrack back up, you want to unbind whatever values are binded to these memory addresses, so that basically reset to their default state, so when we do our next recursion they can be binded to new values. So that's how that works. So yeah, in the knowledge base, prolog's up to here, so it's done the base case now. So then it continues on in the knowledge base and runs into the base case. Runs into the recursive case. So we're up to here now, so we can execute the recursive case. And it's essentially just a matter of lining up the corresponding arguments. So this is argument 1, argument 2, argument 3, argument 1, argument 2, argument 3. So the only real information we have here is the list ABC, so we can sort of populate this structure here. So in doing that, we know that this thing will be really this, because the head will extract A out, and then the tail is just B and C, everything after A, and then we surround them just like how this is written. So we know what head is. Head is A. We don't know what tail is yet, so prolog just gives this a random variable memory address. It's like basically saying it's a question mark. I don't really know what it is yet, but after we've finished, these memory addresses will have a value associated with them. And for completeness, I'll just fill these in. So what this is saying is that, how to read this is that x and y, we don't know what x and y are yet, because G1 and G2 don't have any values associated with them. So, but we do know what they will end up being by saying G1 will be equal to A, G3, and G4 will be equal to G2 will be equal to G4. And the way I got these was that what I'm doing is that the first argument is x, and the first argument here is this head and tail thing. So to find out x, we need to know what G1 is. G1's the first argument position, and so is this. So G1 will be equal to A bar G3, but we don't know what G3 is yet, so we're sort of waiting on that. But once we do know what G3 is, we can evaluate what this ends up to and assign it to G1. And G2 is Y. Y is in the second argument position, so we go down to here and look at what's in the second argument position, and that's G4. So we know that G2 will be equal to whatever G4 is, but we don't know what G4 is yet. So now's the time that we work these out. So I will just fill in the result, which is just BC. And now here's when we recursively call ourselves again. Now prolog starts at the top of the knowledge base, scans line by line down until it finds a factor rule that this unifies to, and it runs into the base case because that's defined first. So we go down to our base case again, and now prolog's job is to basically, give values to G3 and G4 in the first and second argument position, and it does this by looking at the corresponding variables. It's just like what we did up here. So G3 is a variable. To make these two arguments equal, just assign G3 the empty list. So we can do that, equals empty list, and now work out what G4 is. But we can do that by looking at the third argument, which is result. It's just the list BC. And as I said, because prolog variables can accept any value, to make the third arguments the same, we just need to come down here and bind BC to the third argument. And in doing this, that will get shoved into this variable because they both have the same name. And these are in the second argument position, which is G4, so therefore G4 has the value binded BC to it. So we can G4 equals a list BC. So we're getting there, and now it's just a matter of just matching up values to the variable bindings at the top here. So this just means that G4 has BC now. And that means everywhere where there's G4 you can just write BC. So G4 has BC now. That means that we can go over here and this just says G2 equals the value at G4, which is BC. Therefore Y equals BC. And here in the second printing out Y is BC, so that's correct. And next we have to work out what G1 is, and to do that we know that G3 has an empty list, so everywhere we see G3 just put an empty list on top of it. So now we can sort of figure out what this stuff means. So we said G1 equals this thing. We know what G3 now is. G3 is an empty list. So what we can do is, since we know what G3 is, just plonk an empty list down there. And this is sort of a detail in prolog that is sort of easy to forget, but what happens is that a bar with a list following it, the bar actually wipes out this list and unpacks any elements inside it. So what this ends up evaluating to is just A, because we don't care about the bar, just removes that list. So knowing this, then G1 is just going to be A, the list A, and that's what our result shows over here. And that's pretty much this sort of step done. We recurse down. This gave us our bindings for G3 and G4, and knowing what G3 and G4 were allowed us to derive what G1 and G2 were, and the G3 and G4 values were sort of sent up to the highest level, which allowed us to calculate what X and Y were. And this is where it sort of gets a bit messy, is that because we've just done a base case and we're landed here, this is where we're at the moment. So following on from this point, we've sort of done the base case, so now we keep going through the knowledge base, and the next thing that we do is go and start another recursive case. And I'll just clean up some lines here. And like I said before, you know how part of the backtracking and prolog means that all variables that had a binding associated with them, they get the memory address, the binding at the memory address gets refreshed, so it doesn't contain any value. So this means that we're in this sort of area now, and then as part of the backtracking process, it means that all these variables, G3, G4, they get refreshed to contain nothing, and likewise G1 and G2, they get refreshed to contain nothing. So now we're sort of at a clean slate, ready to start again, because if these still had values in them, the next time we go down the recursion level, we wouldn't get the right results, because as you'll see in a second, when we bubble back up again, sort of the result will be built up again. So we'll just continue on. We've printed out this, so we're up to our third one. So we'll do another recursive step here. Alright, so using this as the values that will be provided into the next call. So again, just match up these corresponding arguments and sort of just align them. So we don't know anything about G3 and G4, but we've got some data here, BC, so we can sort of start filling in this third argument here, and we can extract the head. So we know what head is, will just be B, then apply it, and the tail is just a C. So tail is just a C, and we know what the head is. The head's just B. And we don't know anything about the tail or list 2, so we can just keep on assigning random memory addresses to these to denote that we don't know what they are yet, but as we keep going we'll bind a value to them. And for completeness I'll just fill the next level in. And G6. So that's the scenario at the moment. We need to basically this is what's happening. It's a bit confusing, but you have to piece all the different levels together. So we're on this path now. This is the top level, this is the second level, and this is the third level. So what will end up happening is that to work out X, you need to know what G1 is, right? And then to work out G1, you sort of have to do this thing again. You need to work out what G3 is, and to work out what G3 is, you need to know what this thing is. So I'll try and write it out here to make it clear. So to know what G1 is, we need to know what G3 is, and to know what G3 is, we need to know what G5 is, and to know what Y is, G2, so Y G2, we need to know what G4 is, and to know what G4 is, we need to know what G6 is. So G4, G6. So you just go down each level and look at the corresponding argument, and then find out what sort of memory address is assigned to it. So we'll see if this works out. If you're hanging on, still sticking in there, hope this isn't too confusing, but we'll keep going. And the next thing we do is we've got all of our values here, so we recursively call ourselves again. Do a red this time. And then prolog will start at the top of the knowledge base again. It will scan down line by line until it finds something that this matches with, and the base case does. So we've got another base case here, and this means that again we just match these corresponding arguments up, so we have these two things be equal to each other. So therefore we know that G5 is just the empty list, and result here is just the list C, so this list can accept that, and in doing that it's shoved into this list because they're both the same variable name, which means they're the same value, and in doing this it means that these two things, because they've got a relationship with each other, G6 now equals C, the list C. So G6 is equal to C. So this base case is done now. So to make it clear, everywhere we see G5, we'll just put a list above it, and likewise G6, we'll just put a C there. So now we'll just work through this. So we'll do G6 first. So G6 equals empty list. Well, G6 is C, sorry, which means G4 is C. So that means that we said that G2 is C. So here's what will be printed out this time around. Y is C. So we said G4 is C, therefore G2 is C, and therefore that's what Y is. And to figure out what G1 is, which is X, we need to do a little bit more work. So we said G1 was waiting to know what G3 is, so let's work out what G3 is. G3 is B bar G5. So we know what G5 is. I'll just sort of write this out again so we can see it in action. It's B empty list. And remember, the bar following a bar then a list, the bar removes that list. So what we're ended up with is really B. And that means that we know what G3 is now, and G1 was waiting to know what G3 was, so we can shove a B in there, and a bar then a list. A bar removes a list and unpacks the elements inside it, so we're left with this. It's just A, B. So now we know what G1 is. G1 is therefore just AB, and that's what X actually equals, AB. So yeah, you sort of have to work from the deepest level, which we're here. The base case gives us the initial kickstart that we need to get the initial bindings, so you can rebuild going back up. But yeah, if we start this the lowest level base case, the base case gives the last level of recursion the values binded to the variables needed, and if you just sort of work through what the formulas are to derive the highest level result that we need for X and Y, then you can sort of figure out how the result is reconstructed. But I guess you can just think of this really representing what happens when we unrun from recursion. And I'll probably leave it there, because this is what will happen. We'll just do another level of recursion here, and all these G5, G6, G3 and G4 and G1 and G2 would all have their variables unbinded, so that they'd have a clean slate. So when we did this next level of recursion, whatever variables were binded down here, on our way back up, just be rebuilt using a formula similar to this. But yeah, I hope that sort of helped a little bit to understand how the recursion sort of works. But I guess the biggest thing that tripped me up was that recognizing that there's a path that runs throughout the recursion level, and as you continue to recurse, you don't start from back up here. You start from back down here and keep going, but the result is progressively built by going all the way back up again. So yeah, it's a little confusing, but see how you get on. I'll probably post a few more examples shortly on different scenarios, but thanks for listening.